We have two 1.5 kilogram charged objects held in place 0.5 meters apart on a flat frictionless surface. Both have a +2 microcoulomb charge. What is the force between the charged objects? Is the force attractive or repulsive, and why? And what is the initial acceleration of each mass if they are released and allowed to move? So let's tackle the first problem. What is the force between the charged objects? So we employ Coulomb's law here. So Coulomb's law states that the force in newtons is equals to the electrostatic constant K times the charge of the first object times the charge of the second object, and divided by the distance between the two objects. So in this case, the electrostatic constant is a value of 9 times 10 to the 9 newtons meters squared divided by Coulomb squared, and now we times it by the +2 microcoulombs charge. Micro means 10 raised to the -6, and again we have the +2 microcoulomb charge, and we divide this by the distance between the two objects, which is given to us in the question as 0.5 meters. So we can just square that, and we'll have meters squared here. So notice how the units cancel. We have meters canceling here, we have coulombs canceling out, and we're left with units of newtons, which is a force. So once we do this math, we arrive at a force of 0.144 newtons. The next part of the question wants us to address, is this force attractive or repulsive? Now, this force is repulsive. Repulsive force, why? Because they are like charges. So like charges repel, unlike charges or opposite charges attract. And let's move on to part C of the question, which asks us, what is the initial acceleration? So we go back to Newton's law. Force equals mass times acceleration. So acceleration equals force divided by mass. So we have our force that we calculated as 0.144 newtons, and we have our mass of each object as 1.5 kilograms, and we can arrive at an acceleration of 0.096 meters per second square.